Hi everyone, and welcome to our live demo cast, where today we're going to be talking through how we can use EOS Studio to help us migrate a database to Snowflake. So my name is John Harrison, and I'm one of our technical pre-sales team working specifically with the EOS Studio product line. So quick introduction in terms of EOS Studio itself, which I always just kind of like to do quickly with a couple of slides, and just to refresh everyone if they've used EOS Studio before or if you're new to EOS Studio. Our focus with EOS Studio is very much around data modeling. So it's what we call an enterprise grade tool, which can be used by data architects to help them document and also design and modify the data assets within an organization. It supports many popular data platforms, including some NoSQL platforms as well now. And it also allows you to share that information in a few different ways as well to make it more accessible with other people within your organization who might be involved in data governance or data analytic type activities too. What I'll probably do at the end is just for 5 minutes, I might just bring up some of that sharing capability, which comes under what we call Team Server. So quickly going through this. What we're really looking to achieve with EOS Studio as a modeling tool is we're trying to really translate or transform, if you like, the very technical information that's captured as part of a database schema and turn it into more meaningful information. So the slide here is just illustrating that on the right-hand side, if we look at our data sources, look at our data assets, they're going to be stored potentially in many different database platforms. They're going to have a technical schema associated with them. Some of the naming conventions that are in use may not be altogether meaningful. They might be kind of coded in for historic reasons. So if we want to actually transform that and make it into something that's easier to understand, a tool like EOS Studio can help us do that. And the first step really is that what we're able to do is connect to those data sources and extract the information from them with a process we call reverse engineering. And that allows us to create primarily a physical and a logical model representing that information. So on the bottom left of the slide here, we might transform the data assets and from there extract that information and produce a logical data model. And the logical data model can then have more meaningful information in there. So it can have more meaningful names, they can be more business friendly and be presented in a way that's easy for people to understand. And then the next thing we do with EOS Studio, again, using what we call our team edition, our team server, is on the top left. We're also then able to associate those things to an even higher level by creating links into business terms and business glossaries. So we can then map what something means to the business. What's a customer, what's an employee, what's a person, how does that actually translate through into a logical model and then ultimately into the databases themselves. So that's the kind of thing that we can achieve with EOS Studio in quite a simple way, and we'll illustrate some of this as we go through the demonstration. In terms of EOS Studio itself, again, just so we understand a little bit of the terminology that we use, EOS Studio is made up of a number of different components. So on the left-hand side is what we call EOS Studio Data Architect. And this is a Windows application, and we'll spend a lot of the demonstration actually inside EOS Studio Data Architect, taking you through some steps in just a moment. But this is where we'll actually do the work in terms of creating a data model, updating, maintaining data models. So it's typically going to be used by a data architect or a data modeler, a fairly technical person within the organization. And you'll see a list of different features that we support in there on the left-hand side. We won't cover all of those today, but we'll see a number of them. And there's also recordings of other sessions we've done which do cover those specific areas. The central section there is what we call Team Server Repository. Now, this is really something that enables team working. So what this means is we can store our data models in the central location. The Team Server Repository will then manage access to those data models. So you can define security roles, define who has access to those. And also it will support versioning. So we can check out, make our changes, check those changes back in again, and it will make sure that we're not overwriting other changes and that everyone's kind of working nicely together as part of the team. And it also supports things like named releases, which is a snapshot of the data model at that point in time. So you might have your 1.1 production model, your 1.2 production model, and you can always go back and see the differences between those. The final piece on the right-hand side that I'm just going to talk through quickly is what we call Team Server Core. And this adds a web browser-based interface into the Team Server repository. So this is really a mechanism for sharing information from the data models out to a wider audience. So if you've got people in your organization who are more business focused, maybe they're data stewards, maybe they're more business analysts, they're not going to be actually maintaining the data models, but they might like to be able to browse through the data models. They might like to search for specific content in the data models and be able to understand that. So Team Server Core really provides that access just via a web browser, so they don't need to install any software, but enables them to see all that information that we've captured as part of the data models themselves. So that's really the core elements that make up EOS Studio. And for the demonstration today, we'll spend most of our time inside EOS Studio Data Architect. But then, as I say, towards the end, we might just briefly bring up the Team Server Core web interface so you can see how that actually relates as well. Okay. I'll bring this slide back up again towards the end, but there's lots and lots of good information out there on our websites and also on our YouTube channel. So if you want to go and explore further information around EOS Studio, that's just a few kind of pointers as to good, useful URLs to start with. And as I say, I will bring that back up again towards the end of the session. We are using GoToWebinar, so everyone will be muted throughout the presentation, just so we can cover the content easily, but I'm more than happy for you to actually enter questions into the little question and chat panel that's part of the GoToWebinar application. And again, we'll try and make sure that we pause and answer some of those as we go along. Okay, so if you just bear with me a second, what I'm going to do now is just change across to my demonstration environment. And we'll just talk through a few things around EOS Studio. So I just want to make that full screen as well. So hopefully just gives us a bit more information that we can view in there and see. Okay, so this is EOS Studio Data Architect. So as I mentioned, this is a Windows application, and this is where we do the creation of the models and work with the models and so on. Now, just for the purposes of the demo today, I've got an existing model here that's already been created. But where we're kind of coming from with the session we're covering is, if you do have existing database systems that might be stored in a SQL Server, might be stored in an Oracle, and you are looking at how you might be able to migrate those or move those into other environments, specifically something like Snowflake. These are the kinds of steps that you might want to consider and think about in doing that. So the data model we're looking at here, I'll just explain a few things briefly around EOS Studio. We're first of all looking at what we call a physical data model. So this is actually something that was reverse engineered from Microsoft SQL Server. We've then added a few comments and kind of title bars to it just to make it clear that that's the case. If I do click on some of these objects, I can go into see the details behind them, and I'll see the definitions of the columns. I can even see quite specific things related to SQL Server DDL, how that would be created or how it came through from the reverse engineering. I can specify specific storage parameters and so on. So these will all be different depending on the database platform that we're working with. But what EOS Studio allows us to do, which is really very powerful, and I will show this in just a moment, is it allows us to have multiple physical models within our modeling projects. So I can, in effect, go from a SQL Server data model. I then typically produce a logical model from that. So the logical model is a little bit more abstracted away. It's not specific to the platform. But what I can then do is forward generate a new physical model and make that specific to a platform again. So the process here that I'm kind of starting a little way into is we've reverse engineered from SQL Server. We've produced our physical data model. I've also produced a logical data model. And what I want to do now is how would we actually go through and use this as a basis for migrating to other database platforms. So First thing I'm going to explain again a little bit here is just on the left-hand side. As I mentioned, I've got my physical data model, which came from SQL Server. I have actually, I've got another one here, which I was kind of working with earlier, which is why that one says Snowflake against it, but we'll ignore that one for now. We'll generate it and explain the steps from scratch for you. But it's detailing all the different components of that SQL Server database for me. So I've got my tables, my columns, functions, procedures, and so on. So I think the first thing as well, just to understand with a tool like EOS Studio, we're not a 100% migration utility. We are a data modeling tool. So what we are able to do is take things like table definitions, column definitions, and we're able to move those across different platforms. But if you have got specific code that's in stored procedures or packages, depending on the platform, we're not able to convert that for you automatically. There's always going to be some manual intervention required to take those across to the other platforms. And again, if we look at this particular physical model, if we look at the properties behind it, I think if I just click here, at any point in time, I can go in and see the platform that's associated with a physical data model. So I'm just going to say yes. And this one's actually set up against Microsoft SQL Server 2017. And as I said, I generated this model by reverse engineering it from an existing schema. So from there, what I've also created is a logical model. So the logical model is not specific to the database platform, but it contains very similar things. So if I just expand this out a little bit, and apologize if some of you are very familiar with all of this, but I've kind of got a one-for-one mapping really here between table definitions in my physical layer and what we call entity definitions at the logical layer. But the logical model can have them in a more friendly format. So instead of having things abbreviated to ADR, that's actually mapping to something called address at the logical layer. And we have things called naming standard templates, which will help you do that automatically as well. So there's lots of good ways in which we can kind of maintain the differences and update between logical and physical data models. So the first thing that I'm going to do here in terms of our demonstration is I'm going to go ahead and from my logical model, I'm going to say I'd like to generate a new physical model. So yes, let's go ahead and do that. So what's the name of the physical model going to be? Just so I can find it easily, I'm just going to call this one Snowflake, and it's part of our training database, so I'll just put TRN next to it. What's the target platform going to be for this physical model? So again, I've got a comprehensive drop-down list here of what I can select from. So the steps that I'm showing you here are not specific to Snowflake. They will work if we want to do the same process across to other platforms. But as I said, in our demonstration today, we're really going to talk through with Snowflake. And I'm going to go through and say, yes, let's do all of that. I can select the different parts of the data model that I want to be generated into the physical. So we've got different elements. We've got things called business data objects. We've also got our tables. We've got our views, users, roles, and so on that are all part of the selection process. So we'll just work through the model. And there's other options that I could set here, but to be honest, for the demonstration today, I'm just going to go ahead and say, let's do this. And again, a few more options. I'm just going to take the defaults. I'm going to click Finish. So EOS Studio does also support what we call validation rules. So you can actually have a model validation routine be executed against it. And this can just check some kind of static definitions. Do things have a certain number of key definitions? Have they got a description? Have they got an explanation of what they're used for? So there's all sorts of different items that we can select in here if we want to. So you can see a quick example there. We've got duplicate check constraints. Is there more than 10 foreign keys on a table? So things that generally might be regarded as not always best practice. So there is a validation wizard that you can elect to run if you want to. But behind the scenes now, I'm just going to compact some of these things down on the left-hand side. So from my logical model, which was defined here, I've now created an all-new Snowflake TRN model. This is a physical model. And again, if I just want to reassure myself, I can click on this. I can select the database platform, and we'll see that this is set to Snowflake, and it's going to use kind of the Snowflake defaults for that as well. It works in the same way as the data model that we derived it from. So again, any of these items I can, for example, double click and open up, and it's going to show me the same kinds of things. There's my column definitions. my DDL code behind it. In this case, this is now Snowflake specific code that's been generated. And you'll also see some of the options are a little bit different. With Snowflake, we have options around storage parameters. Are they permanent? Are they transient? Are they temporary? Etc. etc. So all of these different options as part of the property editors will change a little bit to reflect the database platform that you've selected. Okay, so in order to run the demonstration today as well, the next steps that we need to go through are basically from this Snowflake specific data model. How would I actually go about implementing that on a Snowflake platform? And again, this is quite a simple example, but it'll illustrate the steps for you. So just before we do that, I'm just going to pause for a second. I'm just going to have a quick look at the panels here to see if we have got any chat or any questions coming in. I think we're good at the minute. And okay, so there is one question there. So we had a question asking about how did we create the logical model. So by default in EOS Studio, when you reverse engineer from a database schema, so if I connect it to my SQL Server instance, by default it will generate both a physical and a logical model for you. So it will handle that correctly in the way in which it brings that through. So you don't need to do anything in particular to have that happen. The logical model will just be created for you. Let me just see if I can just pop that question bar out there. Oop. And where's it gone? Okay. Okay. Right, so we'll carry on. I have got one of my colleagues actually connected here as well, Tim, so he might jump in and answer some of the questions in the chat as well if he gets a chance to do that. So we'll try and keep that kind of going through as part of the demonstration. So what I'm going to do here is I'm just going to jump across to my browser interface. Again, let's make that a little bit bigger. So this is my Snowflake environment. So Snowflake, I'm sure you know, is kind of a cloud-based system. So this is my user interface into Snowflake. And I've got a list of my different databases that I've got existing as part of my my warehouse. And we've got a few different test ones that we've been using here. But what I'm going to do to start with here is I'm just going to go ahead and I'm going to create a brand new blank database in Snowflake. So we'll create this here, and I'm just going to call that I'm going to call it JH for John Harrison, and let's call this TRN demo. So that's our training demo model that we're working, and I can add a comment in there if I want to. So we let that create, and if I just double click onto that and enter it, so it's now created that there, JH TRN demo. You'll see it's basically empty at the moment. So it doesn't have any tables to find. It's got no other information to find against it either. It's just kind of existing there. So what I can now do is jump back to EOS Studio. And I'm now going to basically click through my wizard here, and from my model, control my mouse today, I'm going to say, let's generate the database. So I will just specify a location that I can find it in if I need to, but I'll show you as well that we can also open it up interactively inside EOS Studio. So we'll just put that into my temp folder and we'll just call it Snowflake TRN. Again, we've got some options that we can generate here. So I'm going to select everything. So we're going to create all our tables. There's different options that we can specify around how we want the DDL to be generated. Again, I can choose to select and create the views, the users, the roles. I'm going to make sure that I've got my schema selected there. So it is going to create the actual schema for me as part of that. There's some other options we can specify around that. And the other one that's important to make sure is set is to make sure we generate an owner for the database as well. Okay, so I'm just working through this wizard, and as I said, although we're showing it on Snowflake today, these steps are applicable to other platforms as well. So from EOS Studio, from a physical model, we can ask it to go ahead and generate the SQL code. And I can also be specific. If there's just certain tables that I want to include, I can select them, I can unselect them, or I can do everything. And what I'm going to do here is just say, open up the SQL preview window. So that's going to show me that this is SQL code that's been generated by your Studio Data Architect. It's got a date and timestamp. Target platform is Snowflake. And it's then got the different code that's required to actually create that database schema for us. So I'm going to go ahead and just for speed reasons, really, I'm going to copy and paste this. So I've just copied that definition. And I'm now going to jump across through to, sorry, it's a screen confusion there. I'm going to jump back to my browser where we've got Snowflake running here. So this is my backend Snowflake system, again, based on the cloud. And I'm going to go in and select the worksheet option. And I'm just going to remove that. That's one. Sorry, Snowflake's quite clever. It remembers what you were doing last time in the worksheet. So that was kind of what I was doing just before the demonstration. But here I'm going to paste in that new set of SQL code. And again, if we go up to the top, we should see it's telling us it was created by EOS Studio. I'm just going to check here that I'm going to say that we're going to host this in our warehouse, which is called Demo Warehouse. Not very imaginative, but there we go. And I did create a new database for this one called JHTRN Demo. So we're going to do that. And I'm going to take the default here saying it's allocated to the public schema. So having specified that, should hope to be good to go. So I'm going to say let's select everything and let's run that query. And it's just going to work its way through the execution of that generated code for us now. And it's now just telling us that it's executed that successfully. So now if I go back and look at my databases and go into my, which I'm in there already. So I'm in my databases, I'm in my JHTRN demo database, and we can now see that it's actually created those different table names for us based on the data model itself. So it's from the physical data model, it's generated the code, and then we've executed the code in the Snowflake environment to actually create the tables within there. And of course, we can, you can drill into these as well. So up here on Snowflake, we'll see that it's basically got my different column names defined. It's got the ordering, types, etc., has all been added in there. So that's quite a kind of powerful capability of EOS Studio in that it's able to take the specifics of the physical data model and the platform that we have and actually then generate it in terms of the target platform that we're moving to. So as I said, it's not 100%. It won't do a fully automatic migration for you, but it will give you all the basics of the actual schema itself to be able to start working with that. What I'm going to show you next is how we can also manage this from EOS Studio in terms of when we make changes and have differences and so on that are being applied to the data model, and how do we push those forward. But again, I'm just going to have a quick pause and look at the questions. If there's ones that I can quickly answer, we'll try and do that. Okay, so there's a couple of questions there that are coming through, which are actually really good questions and kind of worth kind of going through. There's one there around the logical model. In fact, let me jump back to that. So if I just go to the data architect, there's a question here around how did we get these business-friendly names when in fact the tables that we reverse engineered from in SQL Server had quite unmeaningful names. Haven't really got time to show that today, but that's down to something called a naming standards template. So what I can do is define a naming standards template, which can then be applied either part of reverse engineering. So I can apply a mapping to say, if I reverse engineer a table called ADR, I actually want that to appear as address in my logical model. And those naming standard templates can be reused across multiple different database types and also used across multiple different database models. So that's really quite a powerful way of reverse engineering and having EOS Studio manage that mapping of more business-friendly names for logical modeling and into the actual physical model itself. A couple of others. So we've got a question there. So Is it possible to create a physical data model directly from the modeling tool? Yes, absolutely. So most of our users, I guess, tend to start by reverse engineering, as they can, if they've got existing schemas, they want to connect to that and generate the model from there. But within your studio, I can absolutely go in here and I can just say, let's create a new data model. And I can start with a blank canvas, a blank model, and start building up the physical tables directly in the modeling surface, and then generate the code from there to actually implement it into my chosen database environment. A couple of others that I'll quickly go through if I can. If I don't answer all of them, I do apologize. We will try and get through a fair few of them. Yeah, so there's a great question here, actually, 'cause it's just about what I want to show here. So there's a few questions about owners. Yes, within your studio, I can select the owner and I can set that in the data model, and that will then be generated into the code. So that's all possible to do that. And likewise, the schema itself as well. I can select the name that I want for the schema, and that will be part of the generated code as well. There's a great question here around what happens if you make changes to the logical or physical models in your studio. How can you actually get that then pushed into an environment like Snowflake? So that's exactly what we're going to show now here. So I could, and I guess traditionally the way we do this is I could go ahead and I could add something into my logical model. From there, I'd push that through into my physical model. And again, from the physical model, I can then regenerate and reuse the code. Just for speed purposes, to be honest here, if I'm going to select my main model here and bring this up again. So this is the model that we just generated for Snowflake. So it's my new physical model, Snowflake TRN. And again, I'm just going to hide away some of the other objects that we have there to try and keep it a little bit more clear for people. One thing I didn't explain, which I'm just going to click on here, is your studio does support something called submodels. They're sometimes called subject areas, and these are a really powerful way of organizing the model. So if you want to have different views onto the model, and say views, I should say different layers on the model, showing different elements, I can do that using submodels. So here, for example, I've got a different view here called conceptual data model. I've got my main, more detailed training model. And if I look up here on my logical data modeling environment, again, I've got kind of other options that I can explore in there as well. So I could go into my conceptual data model where I've hidden away a lot of the detail, because maybe my higher level business users just want to know that we have these high level concepts of a training course and an employee. We might be interacting with an agency who provides a contractor as an employee, and so on. So we can show different levels of detail within different parts of the model itself. But that was a slight digression. So I'm going to go back to my Snowflake TRN here, and I could make that a little bit bigger, I guess, couldn't we? If we look at the diagram and just what we call interactive zoom and zoom into it. So I've got my objects already existing, and these have all been created for me by that code execution on my Snowflake backend. And again, just to keep it simple, what I'm going to do here is I'm just going to add into the physical model. I'm going to say, let's insert a new table. I can go into the property editor for table, and I could add in some extra columns. Again, sorry, my very meaningful names here of AAA and BBB, but it's just to illustrate the point. And I could specify, the other things I want to in here as well. But again, just to keep it simple for this one, I've now added into my data model a new object called entity3. Now, that doesn't exist in my Snowflake backend. That's a new object that I just created on the data model. So how can I go about kind of understanding differences and managing changes? So within your studio, we've got a really powerful utility or wizard that's called compare and merge. So what I'm going to do here is from the menu, I'm going to say compare and merge. It's going to bring up a new set of menus for me. And I can compare a number of different things here. So I can compare to other models. So I can synchronize between logical and physical models. If I've been making changes to the logical, I want to push those into the physical, I can do that. I can connect to my Studio team server repository and compare to other models that I got stored in that central location. I can also compare things like a SQL file, if I extracted that from the database, or I can also go back and reconnect to my data source. So what I'm going to do here is go through And I'm going to specify my credentials to connect to Snowflake. So I just need to key in my password here. And again, we're going to go through here. This can take a few seconds. Obviously, Snowflake's cloud hosted, so it does depend on kind of the internet connection and how fast that's going through. I specify the database that I want to connect and work with. So there's a list of my Snowflake databases, and this is the one that we just created. So I'm just going to select that one and bring that over. And I can specify things like owners and so on in here as well. But for my simple example, I shouldn't need to do that. So I can click through again. Again, more options. We'll just take the defaults. You can go down to quite fine levels of detail and granularity within here. And then what it will do is it will give me a list of the columns on Snowflake. So this is Snowflake on the right-hand side. This is my current data model. So already it's telling me that there's something called entity 3 that's not existing over there. Just for speed reasons, to be honest, and in terms of how the comparison runs, I'm just going to get it to look just for this particular one. But I could compare multiple ones if I want to. And what we should then see is it'll bring up a little summary telling me that I've got something in my data model called entity 3. It's also got some columns defined in here, AAA, BBB, and they don't exist currently on the Snowflake platform. So what do I want to do? I can select things individually, or I can actually say, let's synchronize these. So in my case, I'm going to say, I'd like to take these changes from the model and come up with a way of merging those into my Snowflake schema. Now, EOS Studio will not make those changes directly. It's a data modeling tool. What it will do, though, is it will generate scripts to make those changes happen. And this one's a very simple script, obviously. Do I want to load it into the SQL editor? Yes, let's go ahead and do that. So it's now basically showing me that we've got a script generated, which is going to create that new table that we added into the data model. It's got those particular columns in there. So I could then take that script, put it through my usual processes, checking it, verifying it in my test environments, my development environments. And then once I'm happy with it, then obviously it could then be deployed and applied into the Snowflake system at the back end as well. So there's a few questions about how we do those changes. And so, yes, we will generate alter statements. So the script that gets generated, where it can basically generate an alter, it will do that. We also generate something called an extended alter, where it's sometimes with different dependencies, we want to generate the script in different ways. But basically, by selecting those changes, by a compare and merge in the data model, that allows us to actually apply those, generate the script out from there, generate that change script, and then apply it through our usual processes into the system itself. So I think that answered a few questions that we had coming through here, actually. There's quite a few questions around how do we actually update and compare between things like the logical and physical models and the actual database schema. And again, I'm showing this on Snowflake, but that same type of functionality and feature set that works across all of our supported data platforms. So it could equally well be an on-premise Oracle or an on-premise SQL Server or a cloud-hosted Snowflake system like we've just used today. So I could then take that and apply it back into my Snowflake system. A few other questions I'll just try and cover off as we're going through here. So does the DDL get generated? And is it in the correct order for foreign keys on primary tables, etc.? The short answer to that is yes, that should absolutely happen. I think Tim's be answering some of these as well, entering into the question window. So thanks for that, Tim. Yes, you can create a physical model directly. Can we update the logical and physical models and synchronize them? Yes, absolutely. Can you change the owner? Yes, I think I actually showed that. So the owner can be changed for each of the tables and so on in EOS Studio. If you alter an existing table, it will work in basically the same way. So in fact, I could have done that. I could go into something like my IDERA table here. And again, just for speed, I'll just add a couple of things onto this. We'll add a CCC and a DDD. So I can make changes to that. We could then rerun, compare and merge. Again, I'll do this really quickly. Sorry, excuse me. we could compare it back to my Snowflake system. And then click through. So if you haven't used compare and merge in your studio very much, it really is a very powerful mechanism to kind of allow you to manage these changes and generate the code associated with them. So again, I'll just complete this. And again, just for speed and to make it happen a little bit more quickly, I changed the emp table, I think there, didn't I? Oh no, I didn't. I changed the ADR one. Let's get that right. And what we should see here, and there's always good fun in live demos to go off the beaten track a little bit, what we planned. But now we're seeing that it's identified that that column there has now got some extra columns added into the table. We could do the same thing again. We could select, for example, just those ones actually. We don't have to do everything. If we don't want to merge all changes in one go, we could just select the particular ones that are of interest, do the same thing again, and it should then generate us a SQL script to make those changes in there as well. Ooh, oh, that's because I had that open already. Ooh, bear with me 1 second. I apologise. It's because we had that opened in the first place. I'll tell you, it will work in the same way, basically. I left my SQL window open, so I didn't overwrite the file, which is why it showed the old one in there, so I apologise for that. But it will generate the alter statements to actually add those columns into the table as well. So a couple of the questions just around what our setup is here. So we're connecting using the standard Snowflake ODBC driver. So your studio understands that driver and uses that to make the connection, passing through the credentials in the standard Snowflake way. And I'm running your studio version 19, which was released probably about the last 4 to 5 weeks. The Snowflake functionality specifically was introduced in 18.2, I think. So it has been around a little while. So if you are an existing user and you've got your studio already and you've got a support and maintenance contract with us, you're absolutely entitled to go and download the latest version as part of that agreement and install that and start working with it. So yeah, so there was a question about the driver. You do need to install the Snowflake driver separately. So we don't ship that because it's not our driver. So that is a little bit different maybe if you're used to working with your studio with some of the other connections we make. I'll just show this quite quickly. It's not quite directly related, but if I do want to connect to different platforms for reverse engineering or forward engineering, there's a couple of different choices here. So I can do ODBC. So for Snowflake, I've basically added in the Snowflake ODBC driver, and I've put in some configuration parameters to connect to my Snowflake instance with my username and so on. And likewise, we could do that for Redshift on Amazon as well. So that all just uses their standard vendor ODBC drivers. So you do need to install those. Some of the other platforms, more historically, what we do have is what we call a native or direct connection. I won't go through all the steps here, but if you select that for some specific platforms like Oracle or Microsoft SQL Server, it will directly use the drivers that are existing there as well. So at the end of the day, you get the same type of functionality. If it's a platform like Snowflake via ODBC, or it's a platform like SQL Server via the Microsoft native driver, you're going to get that same ability to reverse engineer, compare and merge, generate the SQL scripts, and so on. It's just a different type of connection that we're using in here. Okay, other things. So there's a question there about can the scripts be pushed directly into a Git repository? We don't have direct integration into tools like that, but the DDL files and the script files are all just generated and can be stored on the file system, which can then of course be added into a repository or wherever you want to put it. As I say, it's not directly integrated, but everything we're producing there is just a script file, so you can put that where you want to put it and use it in that way. Okay, so I think we've covered most of the items that I wanted to cover there. Let me just jump back over here again. And maybe just a quick, I think, the last few minutes before we wrap up. And again, we'll keep an eye on questions. So if people have got more questions, then please feel free to put those in there. So just as a quick recap, in essence, what we've shown today is that with EOS Studio, we can reverse engineer from an existing database, which could be SQL Server or Oracle or something else. Or we could create a new data model, by hand. From those data models, we can then generate physical models to correspond to different platforms. So that enables me to actually generate the definitions for my objects, my tables, my columns, onto a platform like Snowflake. We'll generate the code around that, which you can then take across, implement on that platform, and basically start migrating and moving across from there. The live demos that we do, they are quite fast-paced. I always think myself as I'm doing them. So we have covered quite a few things here. The marketing team, we do record all these. And the marketing team, via GoToWebinar, will actually email you a download link. So if you do want to rewatch it, you can do that. It'll also be made available kind of for the people who couldn't attend. The other thing, I guess I just wanted to quick look at the questions. So, okay, I've got one comment saying the audio is bad, but I'm not aware that anyone else has said that. So I do apologise if that is the case. But as I said, it will be recorded. So hopefully, if you missed any parts of it, then you can go back and re-listen to it. Actually, thank you for that. I have got someone saying that the audio seems fine to them. So maybe that's just a local issue. Another question around the object model functionality. Is that available in all EOS Studio versions? So without getting too involved in the detail, if I just bring back up this slide again here. So EOS Studio is available for purchase either as just a standalone single user data architect tool. So the models then will be stored on your file system. It is available for something that we call EOS Studio Professional, which then adds the repository. So you can store things in a central location and version control them. And then it is available with something called Team Server Core. But all of the modeling capability, all of the creation of the objects, the reverse engineering, all that kind of actual modeling, that's all done within the Data Architect tool. So even if you purchase just the standalone Data Architect, if you're just using it yourself, you're going to get all that different levels of functionality that we've seen in terms of reverse engineering, forward engineering, etc., etc. So in the last minute or so, the last thing I did want to show is actually maybe just give people an idea of Team Server Core. And the Team Server Core is really a way to actually share the contents of the data model. So if I just jump across now to my environment here, that one, yeah. And so all I'm running here now is just a web browser. And what I've done is I've added a model into my EOS Studio repository, and I've then done what we call published it out to Team Server to make it available via the web browser. So if I just make that a little bit bigger, actually. So the first thing I can do is if I know what I'm looking for, if I know it's a particular project or particular thing that I want to see, I can use the Model Explorer to browse through and find those. And here you'll see that we've got kind of my definitions of that model that we're looking at inside EOS Studio. And I can click on there and it will generate a HTML rendering of that diagram for me. So this is read-only, I can't change it, but I can zoom in, zoom out. I can also double click as well, actually. So if I click on address, that's going to take me into the details behind that particular entity so I can see the attribute details, the keys, and so on. So it provides that mechanism for publishing the information out there and making it available to a wider audience. The other thing that we have just updated in version 19, which is really quite a cool new feature, is if you are looking at how you can better understand and link things like business terms, that might be defined by different parts of the organization back into implementations and data models. We did some really nice little updates in the functionality we have here. So if I, for example, go and search for a business term called party, I click on there, we get a description, etc., etc., etc. But what we've added in version 19 now is actually the ability to graphically represent that. So I can now click on things and I can see that actually party is related and might be made up of an organization or a person. That person could be an employee, they could be a contractor. So I'm starting to see a kind of hierarchical view of the hierarchy behind that. Again, these are clickable, so I can now click into a business term like employee, and I could now ask to see, well, actually, how does that relate to things like attribute definitions? And I can see, if I click on the right one, I can see in there that we've got something called an employee, and it has those particular attributes defined, and it also has these particular related objects behind it as well. So we can navigate around from a high-level business term definition through into the data models and understand the more technical information behind that as well. And as I said, the nice thing here is it's all browser-based, so that can be shared around the organization with the team server core license enabled. One last question, how do you go about getting the latest version? As I said, if you have got your studio already and you've got a support contract with us, you're entitled to get these latest versions. Hopefully you've got a contact for your IDERA salesperson or account manager. But if not, if you just email to either info@idera.com or sales@idera.com, that will be picked up on and we'll get you kind of hooked up with the right people to make that happen. But that shouldn't be a problem. If you've got current support and maintenance, you can download the latest version and start using it with the new features. Oh, sorry, question, just a clarification, the web version. So the web version, that is an add-on. So if we look at my slide again here, it's kind of the basic data architect edition, and then it goes up to what we call enterprise team edition and team server core. So that would be an additional cost potentially, depending on the license that you already have. But again, if you email us or contact your account manager, they'll be able to explain, kind of how you might be able to upgrade to that or any particular costs that might be involved in taking that license. With that, I shall let you all go back and crack on with other things that you may be doing. I'd just like to say thank you for attending. And as I said, there's contact forms up on the website if you do want more information about anything, or drop us emails in there as well. Okay, thanks very much, everyone.